In triangle RST, show that midsegment MN is parallel to segment RS and that the length of segment MN is equal to 1/2 times the length of segment RS. To begin this problem, first label the coordinates of the vertices of triangle RST. The coordinates of point R are 2, 5, the coordinates of point S are -2, 1, and the coordinates of point T are 4, -1. Next, you need to find the coordinates of points M and N. Because segment MN is a midsegment, point M is the midpoint of segment RT, and point N is the midpoint of segment ST. So, to find the coordinates of these points, you can use the midpoint formula. To find the coordinates of point M, let x1 equal 4, y1 equal -1, x2 equal 2, and y2 equal 5. You can substitute these values into the midpoint formula. When you simplify, 4 plus 2 gives you 6, and -1 plus 5 gives you 4. 6 divided by 2 gives you 3, and 4 divided by 2 gives you 2. So, the coordinates of point M are 3, 2. To find the coordinates of point N, let x1 equal -2, y1 equal 1, x2 equal 4, and y2 equal -1. You can substitute these values into the midpoint formula. When you simplify, -2 plus 4 gives you 2, and 1 plus -1 gives you 0. 2 divided by 2 gives you 1, and 0 divided by 2 gives you 0. So, the coordinates of point N are 1, 0. Now, two segments are parallel if they have the same slope. So, to show that midsegment MN is parallel to segment RS, you need to show that they have the same slope. You can find the slope of each segment using the slope formula. To find the slope of segment MN, let x1 equal 3, y1 equal 2, x2 equal 1, and y2 equals 0. You can substitute these values into the slope formula. When you simplify, 0 minus 2 gives you -2 in the numerator, and 1 minus 3 gives you -2 in the denominator. -2 divided by -2 gives you +1. So, the slope of segment MN is 1. To find the slope of segment RS, let x1 equal 2, y1 equal 5, x2 equal -2, and y2 equal 1. You can substitute these values into the slope formula. When you simplify, 1 minus 5 gives you -4 in the numerator, and -2 minus 2 gives you -4 in the denominator. -4 divided by -4 gives you +1. So, the slope of segment RS is 1. Now, as you can see, these two segments both have a slope of 1. Therefore, because they have the same slope, segment MN is parallel to segment RS. Finally, to show that the length of segment MN is equal to 1/2 times the length of segment RS, you can find the length of each segment using the distance formula. To find the length of segment MN, again let x1 equal 3, y1 equal 2, x2 equal 1, and y2 equal 0. You can substitute these values into the distance formula. When you simplify, 1 minus 3 quantity squared gives you 4, and 0 minus 2 quantity squared gives you 4. 4 plus 4 gives you 8, and the square root of 8 is equal to 2 square roots of 2. So, the length of segment MN is equal to 2 square roots of 2. To find the length of segment RS, again let x1 equal 2, y1 equal 5, x2 equal -2, and y2 equal 1. You can substitute these values into the distance formula. When you simplify, -2 minus 2 quantity squared gives you 16, and 1 minus 5 quantity squared gives you 16. 16 plus 16 gives you 32, and the square root of 32 is equal to 4 square roots of 2. So, the length of segment RS is equal to 4 square roots of 2. Now, notice that 2 square roots of 2 is equal to 1/2 times 4 square roots of 2. Therefore, the length of segment MN is equal to 1/2 times the length of segment RS.